Algebra 2 trigonometry, radical equations. Solve. Square root of 6x plus 10 equals 4. How do I know it's square root? Because there's not a number here. If there was a number, if there was a 3 there, it'd be cubed root. This is square root. And the majority of this lesson is going to be dealing with square root. Maybe I'll throw a cubed root at you towards the end in class or something like that to challenge you. But the majority is going to be square root. So this is square root of 6x plus 10 equals 4. And so we're solving what is called a radical equation here because it's a radical and it's an equation. Makes sense. You solve this just like you solve every equation you've ever had. Like if you had a 2x minus 4 equals 7, you would add 4. The reason you would add 4 is because it's the opposite of minusing 4. It's the inverse operation to move it to the other side. And then later on you would divide 2 because this is 2 times x, and dividing is the inverse of multiplication. So to solve equations, you're trying to get x equals. And so what that means is I need to move this plus 10. I need to move this square root symbol, and then I need to move this times 6 and so on. And the way you move or undo those things is with inverse operations. And so this is no different than anything you've ever done before. First, we always tend to deal with adding and subtracting things away. And so like this plus 10, I can simply minus 10 to both sides. And so I end up with the square root of 6x equals negative 6. Now, also notice that this plus 10 was not in the bar for the square root. If it were, that would change things a little bit, and we'll see that probably in the next example. All right, so at this stage, now if it was just 6x equals negative 6, I would divide 6, but it's not. It's the square root of 6x, and I need to deal with this first. So how can I get rid of square root? Well, how did I get rid of plus 10? I minus 10. I did the inverse operation, and the inverse operation of square root is squaring. So I'm going to square both sides. And when you square a square root, you end up with what was inside of it. Because square and square root undo each other just like multiplication and division do, just like addition and subtraction do. So the square root of 6x squared is 6x. And negative 6 squared is positive 36. And now I can divide by 6 to do my final inverse operation, because this is 6 times x. I do the inverse operation of division, and x equals 6. Now you always want to check your answers in radical equations. There's a couple of things we do throughout Algebra 2 trigonometry. Now you should always check your work in general mathematics, just because that's what you should do to verify it's correct. But there are a couple of things that we do that you really have to make sure you check, because it's very common that there's traps built in that your answer is not really your answer. And this is one of them, so you really want to check these. So let's say if x is 6, that would be 6 times 6 is 36. And the square root of 36 is 6 plus 10 equals 4. 6 plus 10 equals 4? No, it doesn't. That doesn't work. So what do? Well, you would need to cross out the answer and write the word reject next to it. Now, this isn't going to happen all the time, but it does happen some of the time. So you have to be careful with this. So we minus 10 and then did everything, so on, so on, so on. Really, it was at this stage that we probably could have guessed that was going to happen, because you can't have a square root equal to a negative. And we're going to talk more about that another time, but that was kind of a hint. But simply checking it like I did verified that. Now, if I didn't check it, I would have stuck with answer C and already got the question wrong. So what does that mean the answer is if my only choice here was rejected? Well, that's what this symbol right here is. The 0 with the slash through it. It's a symbol for empty set. It's a symbol for no answer. And so that's what's happening here, is that there is no answer that works out. Okay, let's see here. Next one. So the square root of 6x plus 1 equals 5. Now, this is what I was talking about before. Notice that this plus 1 is under the square root. That means I can't subtract 1, at least not yet. The only thing over here is what's under the square root, so I need to deal with that first, and that's going to be squaring to get rid of that square root. So that'll leave me with 6x plus 1 equals 25. Inverse of plus 1 is minus 1, so 24. Inverse of times 6 is divide 6 is 4. So x equals 4. But let me test it first. Let me check it. 6 times 4 is 24, plus 1 is 25, square root of 25 is 5, and you're good to go. Now, if you need to write out a check to help you with the math, you can. I just quickly did that in my head to verify. The solution set of square root of x minus 2 plus 3 equals 0. So again, I want to first, deal with, see how this plus is not under the square root, so I can simply move that by minusing 3 on both sides. So the square root of x minus 2 equals negative 3. Now right here, this is kind of what I was talking about before. This is now the square root equal to a negative. I'm starting to think that maybe this is it, and this is the same thing as that symbol we saw before. None of these would be no solution. But let's solve it, see what we get, and then test it. So we square both sides. X minus 2 equals 9. X equals, add to 11. So let's see if this is 11. 11 minus 2 is 9. Square root of 9 is 3. 3 plus 3 is definitely not 0. So again, it's an option where there's no answer. And that step right there, that whenever you have a radical equal to some negative number, it's not going to end up working out. So one more here. I see the square root of 2x plus 14 under the square root. Minus 3 is not, so I can move that over, and it's equal to x, not a number. So this one's going to be a little bit trickier. Add 3 on both sides. That'll give me the square root of 2x plus 14 equal to, what's x plus 3? Well, it's exactly that, x plus 3. They're not like terms, can't add them together. So now I have to get rid of this square root. I'm going to do that by squaring both sides. And this is a special concept that comes up all the time. This is x plus 3 squared. This is called a binomial squared. And we see this sprinkled throughout a lot of topics in Algebra 2. It comes up very often, and you really need to be careful with this. The left side here, that's 2x plus 14. That we know, that's no big deal. All right, but x plus 3 squared, that is not x squared plus 9. When you're squaring a number, you square it, or a monomial is squared. But this is a polynomial, specifically a binomial. And when you square an expression like this, you have to realize that it's x plus 3 times x plus 3. And this is really a concept of FOIL, or distribution. And so you're going to end up with a trinomial. And so you have to do all your FOIL stuff like that. Now, there is a shortcut, a mental shortcut for doing this, where it's going to be your first term squared, which is x squared, and the product of each other. 3 times x is 3x, but you're going to have 2 of them, so you double it to 6x. So again, what I just did was I multiplied these together and doubled it. And then my last term is 3 squared, 9. All I just did was a shortcut for FOIL, because if I were to FOIL this out, I'd see x times x is x squared, x times 3 is 3x, 3 times x is 3x, and 3 times 3 is 9. And then you combine the middle terms to get the 6x I was talking about before. And so that's why I said you multiply them together, 3 and x, because you do that. Here was your 3 and x, and here was your 3 and x. And that's why we double it, because in FOIL it happens twice. When you do a binomial squared, your 2 terms end up being in the middle are the same, and so you could just do it once and double it. Anyways, if you need to do the FOIL, you can. If you could do that mental shortcut, you can. So now I see that this is going to end up being a factorable term, so I'd have to set it equal to 0. I can minus 2x on both sides, minus 14 on both sides. That's going to leave me with x squared plus 4x, and then minus 5. Again, I subtract the 2x, and I did it here. I subtract 14, and I did it here. I can factor it to x plus 5 and x minus 1. Those numbers multiply negative 5, add to 4, and that's going to end up, when I solve for each of them, equal to 0, x equal to negative 5, and x equal to positive 1. Now, that's not even close for any of these, so I don't know where they came up with those. So the answer is none of these, but it's not, I don't like this. I wish they had these as choices. But you have to be careful with these, that you need to check these, because a lot of times when you're doing these, one of them will work, but one of them won't. So let's see if they both work, and if not. And I want to test them up here in the original. So if I plug in a negative 5 here, 2 times negative 5 is negative 10. Plus 14 is the square root of 4, which is 2. And that'd be minus 3 is negative 1 equal to x, which is positive 1. So this does not work. And so I have to cross it out and write reject. How about negative 5? If I plug in a negative... Oh, actually, wait, that's what we did. We didn't test the 1 yet. Well, we would have ended up with negative 1 equal to negative 5, and that doesn't work. So this was the one that didn't work. Well, let's try 1. If I plug in a 1, 2 times 1 is 2. Plus 14 is 16. The square root of 16 is 4. 4 minus 3 is 1. And we plugged in a 1, so it's equal to 1. So that one does work. So this is my only solution. So it's not, and none of these is true. The answer would be D here, but the real answer should be 1. And you'll see that, I just want to jump ahead to maybe another question here. Like in this one, further down your sheet, what you're going to do in class, this is going to be a similar problem like what we just did. And notice that a couple of the choices have 2 answers, and then a couple of the choices only have 1. This is because there's a good chance that maybe they'll both work, but there's a good chance that one of them won't work, and you'll have to decide which one does work. So these choices make a lot more sense than what we were doing over here. All right, see ya.